problem number 1, I'll do that one up here. I'm going to do number 1 up here. Problem number 1 asks us to write an expression that describes this set of solutions. Now, this book is using this notation right here, these brackets like this, these square brackets, to indicate that the point is included. Now, if the point, all right, so this means included. If the point is not included, they'd be writing parentheses. That means not included. Now, often what you'll see instead is that you'll write a closed circle for included and an open circle for not included. So the way I'm seeing this one, this is actually including that point. So where are the values that make this thing true? Well, look, they're all to the left, right? All the values are to the left of what? What do we get here? 0, 1, 2, 3, 4. That must be a 3. So they're to the left of 3, so they're all less than 3. So I'm going to describe this by writing this. All the values that we want, all of these x values, all those x values are less than 3. So all those x's are to the left of 3, but possibly equal to 3. So I'm going to write this as x less than or equal to 3. And I'm writing the less than because of this sign right here, which means that that point is actually included. And all the values are to the left, right, to the left of 3. Now, number 2, we want to write this. This is in inequality form. We want to graph this and write it in interval form. So I'm going to graph it first. So to graph this, I'll just draw a number line, and I'll label it x because x is what our variable is. And it says all the x's are to the left of 7, possibly equal to 7. So I'm going to come over here on the number line, and I'm just going to draw a 7. I don't need all those other numbers. And everything to the left, right? Where are the x's? The x's are to the left of that 7. So they're all over here. So I'm just going to draw my number line and solution set like that. And then, what have I got? I want an interval notation. So an interval notation, now interval notation goes like this. You have a lower limit, comma, and then an upper limit. A lower value and an upper value. Now I know what the upper value is here. The upper value is that 7 and it's included. So I draw it like this. Included and 7. And then the lower value, well, look what happens here. This just says that x is less than 7. There is no lower bound. There's no lower bound here. It just keeps on going. It goes off to the negative direction, and we're going to name that as negative infinity. And I put an open parentheses around the infinities because infinities are never included. Right? 7 is a number, you can include it. Infinity is not a number, you cannot include it. No value can ever equal infinity. So there's our solution here in terms of the graph and the interval and the, okay, I got the graph notation, the interval notation, and the inequality form. In number 3, we have that x is to the right, x is greater than, to the right of negative 4. Let's draw ourselves a number line here. And I'll get it to draw. I'll draw a number line, I'll label it x, and I'm going to locate negative 4, and because it's greater than, strictly greater than negative 4, not included, I'm going to draw an open circle at negative 4. Just pick some point on the number line, label it negative 4. Now, back over here in number 2, that 7 was included, right? There's the equal, so I got a closed circle. Now there's no equal, so I draw an open circle. Negative 4 is not included, and all the values are to the right. You can see that by this. The x's are to the right of negative 4. So here's the inequality form, here's the graph form, and now the interval form goes like this. Remember, an interval goes like this, over here. Lower limit on the left, upper limit on the right. So lower, upper. So the lower is negative 4, but that negative 4 is not included. So negative 4, not included, I'll put parentheses around it, comma, and the upper limit, well, look at this. It just keeps going to the right. There is no upper limit. It goes off to infinity. So I'll draw an infinity sign here, just to represent that it keeps on going, and infinities always have parentheses around them. Infinities are never included. So here's our three forms. We've got the inequality form, the graph form, and the interval form. In number 4, this says that 3 is less than x. So 3 is to the left of x. Now, here's how I'm going to write this instead. I think of it this way. If 3 is less than x, then don't you think that it has to be true that x is greater than 3? Think of it like this. If you are younger than I am, then I am older than you are. You are younger than me, I am older than you. So it's just like taking this whole thing and flipping it over. Just flip it over, right? Flip it over. So if 3 is less than x, x must be greater than 3. And now that just gives me a better sense of what to draw. Here's a number line, I'll label it x. Now, the 3, I'll put a point at 3, but it's not included, right? There's no equal sign here. So this is going to be an open circle at 3. And where are the x's? The x's are to the right, right? X is greater than, to the right of 3. So here's our graph. And then in interval form, right? Interval form has lower limit, upper limit. So what we're going to have here is 3 is the lower limit. The upper limit, that just goes off to infinity, right? 3 is not included, so parentheses. Parentheses always around infinities. Now, let's just check something back at the very beginning. This says 3 is less than x. So 3 must be to the right of x. So look what we drew. Here's 3 is to the left of the x's. 3 is to the left of the x's. Look what we drew. 3, sure enough, 3 is to the left of all these x's.